Assalamualaikum and greetings. Okay, in the benzene topic, there are two most commonly asked questions. The first one is the synthetic sequences in order to prepare benzene derivative. The second one will be the electrophilic substitution mechanism. In this video, we'll be focusing on number one. So if we return back to our previous question in our previous video, we already encountered this question. For instance, predict the synthetic pathway to produce the following compound from benzene, including the following compound from benzene, including reagents and condition. So basically, this question will require you to produce the product. For instance, if we look at A is ortho-nitrobenzoic acid. In order to do this, you need to know how to draw the correct structure based on the name. So ortho-nitrobenzoic acid, we're going to draw the benzoic acid first. So benzoic acid is being drawn as a benzene with attachment to the COH. In this case, number 1 will belong to the first carbon attached to the COH, and then we draw the substituent, which is nitro, which is positioned at ortho. Remember guys, ortho is positioned between 1, 2 or 1, 6. Okay, it's just next to the parent chain. So we can put the nitro. Nitro is being represented by NO2. Alright, and then it can be positioned at carbon number 2 or carbon number 6. Okay, doesn't matter. Right, because it is in ortho position. So the question does not test us on how to write down the end product. The question requires us to give the synthetic pathway from from a normal benzene, okay, yang tak ada apa-apa attachment, and then we want to convert it into COH with attachment to the NO2. Or for the second question, starting from benzene, we're going to produce metachlorobenzene sulfonic acid. Okay, benzene sulfonic acid is benzene together with the SO3H, and then it is positioned at meta, which means that it is positioned at number 3 or number 5. So chloro is being represented by Cl. Okay, can be written at carbon number 3 or carbon number 5 of the structure. So the idea is, in order to answer this question correctly, first and foremost, you need to get the product right. After that, we're going to plan on how to answer this question. Okay, similar question will be looking like this. Question number 10, outline the synthetic sequences to synthesize the following compound from benzene. Okay, the keyword here is the synthetic sequences. Okay, this is the keyword. So similar to the previous question, it's going to give you the product, and then you're going to start with benzene to produce the respective compound. Right, another form of question. Okay, this was taken from different semester, Ni soalan nombor 10 ni, outline the synthetic sequences to produce the following compound from benzene. Sama juga, the keyword is synthetic sequences, and then it start from benzene. We have the para-nitroaniline, which is positioned between 1, 4, and then we have meta, which is positioned at 1, 3 or 1, 5. Just choose one. Either way, it's still a meta position. In order to answer this question, what you need to do first is, you need to understand the concept of the electrophilic substitution reaction. In general, there's only 5 reactions. It's only 5 reactions regarding the reaction. So, the name is halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and Friedel-Crafts acylation. Please pay attention that if we are referred to alkylation, it only comprises of R. If acylation, it is between R, C, double bond O. Okay, the similar thing is Friedel-Crafts is they going to use the same catalyst, which is aluminum chloride. right? And then for alkylation, we will be using RCl. For acyl, it will be RC-OCl, right? This is the basic of electrophilic substitution reaction. Okay, for instance, if we perform nitration, it will be looking like this. We have benzene, and then we add nitric acid and also sulfuric acid. What's going to happen is any hydrogen which is free on the benzene ring will be replaced with the NO2. So in this case, we have 6 possibilities. However, if you draw any one of it, the answer is correct. So I'm going to choose the top hydrogen to be replaced. And the side product will be H2O, where the hydrogen from the benzene combined with the O2 from the nitric acid. Just to tell one thing, it is very important to memorize both of the reagent and reactant of the electrophilic substitution reaction. Okay, you cannot ignore it. Okay, kena ingat yang atas bawah because yang atasnya ada reagent, bawah ni adalah the catalyst. It is the catalyst. Okay, ada example. Jadi benzene sulfonic acid, for instance, you need to memorize the SO3 and also H2SO4. So again, the idea is if you have a benzene, then we react it with SO3 together with catalyst of sulfuric acid. What's going to happen is the product will be a benzene attached to SO3H. So again, the first thing that you need to know is you need to memorize all of the reactant involved in the electrophilic substitution reaction. There are 5 main reactions: halogenation, nitration, sulfonation, Friedel-Crafts alkylation, and also Friedel-Crafts acylation. This is the reaction name, while the mechanism will be called electrophilic substitution. Okay, this is the first thing that you need to know. The second thing you need to know is, okay, the ortho-para directors and also the meta directors. Okay, what does this mean, ortho-para directors and also meta directors? So as you can see on the list, okay, ortho-para directors referring to the substituent which have NH2, OH, OR, or the alkyl group, and also the halogen. This is the ortho-para directors. For the meta directors, it comprises of the SO3H, C triple bond N, NO2 from the nitration, and then we also have the COH from the carboxylic acid. So let me explain first on what is ortho-para and meta directors is all about. Alright, imagine this benzene act as a house, a rented house. Right, for the house it has 5 rooms. Okay, 5 empty rooms. Rumah kosong ada 6 bilik. So let's say the first person who entered the house will become the landlord. Orang pertama yang masuk rumah akan jadi landlord. So let's say we have we're going to insert okay, let's say we're going to insert chlorine first. So in this case, in order to insert the chlorine into the ring, okay, we need to put Cl2 together with the FeCl3 as the catalyst. Yes, you need to memorize this. So what's going to happen is one of the hydrogen will be replaced by the Cl. Alright, bilik kosong tu telah dimasuki. So apa yang akan berlaku adalah the benzene will attach to the Cl without disturbing any of the other hydrogen. Okay, dia akan masuk bilik kosong. So again, the first person who entered the benzene ring will become the landlord. Okay, now first room has already been occupied. So ada 2, 3, 4, 5, 6. Okay, ada 5 bilik lagi yang kosong. Alright, so chlorine will act as the landlord, and in the same time it is the ortho-para directors. So whenever other substituent wants to go inside the benzene ring, it must listen to the chlorine. For instance, let's put NO2 inside the ring. In order to put NO2, we need to add nitric acid together with sulfuric acid. What's going to happen then is the same process where the NO2 will go to any of the empty room. However, since chlorine is the ortho-para director, it can only allow the nitro go to the ortho or para position. What is the ortho-para position? Okay, ortho is the 1,6, so it can be 1,2 or 1,6. So the nitro can only enter room number 2, number 6, or number 4. So what we're going to get next is, it will be looking like this. This will be NO2, or the other option, we have the benzene, we have the Cl, NO2 will be positioned at carbon number 4, or it can also be positioned at carbon number 6. This is just to tell you what is the function of the ortho-para directors. Alright, so although the nitro itself is a meta director, okay, tapi dalam hal ni dia bertindak sebagai penyewa saja, pasal klorin adalah tuan rumah. Jadi dia kena dengan cakap klorin, kat mana yang boleh masuk. Okay, again, chlorine is the ortho-para director. It can only allow the nitro goes to carbon number 2, number 4, or number 6. What happen if we change this situation? For instance, instead of chlorine masuk dulu, kita masukkan nitro. So it will look like this. First it was benzene, and then the nitro comes first. In order to add the nitrogen, we put nitric acid together with the sulfuric acid. So this will become nitro, and then since nitro is the first one to enter the benzene ring, so nitro will become the landlord. We know that nitro is what we consider as meta director. Jadi dia akan mengarahkan sesiapa yang masuk selepas tu, dia akan masuk dekat bahagian meta, which is carbon number 3 or carbon number 5. Now came along chlorine. To insert the chlorine, we need to add the Cl2 together with the FeCl3. So we're going to add, in this case, we're going to add the Cl attachment to the benzene ring. Ingat, it can only enter empty room which is positioned at carbon number 2, number 3, number 4, number 5, and also number 6. However, it cannot enter all of the position. It can only enter carbon number 3 and number 5 because arahan daripada tuan rumah. Walaupun chlorine sendiri adalah ortho-para director, tapi memandangkan dia menyewa, jadi apa yang dia perlu dibuat, dia kena dengan cakap nitro. So what going to happen is, if you have the nitro compound, okay, I'm going to delete this first to make it clear. Okay, originally it was nitro. The chlorine can only be positioned at number 3, or it can only position at carbon number 5. So guys, this is the concept of ortho-para director and also meta director. Please take note that, okay, the structure of ortho, it is the same for carbon number 2 and carbon number 6, right? It will be considered as same. While if you draw at carbon number 3 or number 5 for meta, it also considered as the same, because you're going to assign the same number, the same name. Okay, let's take a look at the questions. Okay, I'm going to use this one for the first example. Sequence nitroaniline, ethene, nitrobenzene. Alright, for this one, okay, for this question, what we're going to have is, we're going to synthesize the A first. I guess I'm going to show B because it's straightforward, okay? So the question again, predict the synthesis pathway to produce the following compound starting from benzene. So let's say for B, okay, we need to draw first the overall picture or the full chemical equation. The question asks us to draw the compound of metachlorobenzene sulfonic acid, okay, which means that the benzene sulfonic acid is the parent. We just draw SO3H. Alright, and then we're going to have chlorine position at meta, which is 1,3. So I just draw the Cl there. So we already know one thing is, in order to insert SO3H, we need to perform the sulfonation reaction, which can be done by adding SO3 together with sulfuric acid. And we know that in order to insert the chlorine, we need to put Cl2 together with FeCl3. Okay, we already know the ingredient. However, it's like cooking, we need to put everything in sequences. Kita nak masukkan sulfonation dulu ke kita nak buat chlorination dulu? Okay, in order to determine this, first and foremost, we're going to take a look at overall structure of compound. So from the structure, you notice that chlorine adalah ortho-para director, SO3H adalah meta director. What about the overall structure? The overall structure is positioned between 1 and 3, meaning that it is meta position, which means that meta yang akan dimasukkan dulu. Pasal dia yang akan bagi arahan nanti. Okay, anda perlu berada dalam keadaan meta. Sekali lagi Okay, we already know the recipe on how to add SO3H. And then you also know how to insert chlorine into the structure. The question is, which one should come first? That's why we need to refer to the overall structure. Okay, identify the substituent. Again, SO3H is a meta, while Cl is the ortho-para director. Okay, memandangkan structure produk yang dikehendaki adalah meta, means that we need to insert the meta compound first, which is SO3H. So the structure we'll be looking at this. We start off with benzene. We add SO3 together with the sulfuric acid. Then we're going to get SO3H. Then after that we add chlorine in FeCl3 to get the compound SO3H, and the chlorine will position at the meta position. Okay, apa masalah dia kalau kita masuk Cl dulu? So let's say if we add the chlorination first, we start with the benzene, and then we add chlorine and then FeCl3. So the first product will be Cl, and of course there's side product of KCl. If we add SO3H later by adding SO3 together with the sulfuric acid, the SO3H will not position at meta. Why? Because chlorine is the ortho-para director. Dia tak akan benarkan SO3H berada dekat meta. Dia akan suruh SO3H berada dekat ortho ataupun para. So, the structure that we're going to get is not as the same as the required by the questions. That's why not only it is important for us to know what is the ingredient to produce those things, however, in the same time, kena tahu sequences yang betul. After all, this question asks for the synthetic pathway. It must follow the correct sequences. Okay, kita tengok soalan yang lebih similar. Soalan-soalan lain. Okay. Let's say we have M-ethyl nitrobenzene. Okay. Kita ambil soalan yang ni pula. Okay, draw the overall reaction first. First we have benzene. And then the question asks us to outline the synthetic sequences to produce M-ethyl nitrobenzene, which means that we have nitro, and then we have ethyl position at the meta. Okay, again the same thing. The meta is located at between carbon 1,3 or 1,5. So we just wrote it simply like this. Alright. So in this case, what we need to do is we need to insert the alkyl group together with the NO2. In order to add NO2, okay, it's quite familiar. We're going to add HNO3 and also H2SO4 nitric acid together with sulfuric acid. Then we're going to get the NO2 structure. Okay, this name of the reaction is nitration. In order to add the ethyl group, we need to add 2 carbon from CH3, CH2, Cl while being catalyzed with AlCl3. This is what we call as the Friedel-Crafts alkylation. Alright, because the carbon-carbon, okay, the carbon-carbon here is represented by R. And then the catalysis AlCl3. Right, you already know the recipe from the electrophilic substitution reaction. The question is, which one that we're going to add first? Is it nitric acid or is it the Friedel-Crafts alkylation? Again, the same approach that we do is we take a look at the product first. So as you can see here, the product is in the meta configuration. And then the substituent which is available to us is NO2 is a meta director, while the ethyl or the R is obviously an ortho-para director. Since the product is in meta configuration, clearly the nitro should come first. Perlu masukkan nitro dulu. So this is the reaction it looks, okay. First, we start with the benzene. We perform the nitration reaction, HNO3 together with sulfuric acid. Then we're going to get nitrobenzene, followed out by the addition of ethyl chloride together with the aluminum chloride as the catalyst. Then we're going to get the nitrobenzene, which have attachment to the CH2CH3, okay, from the alkyl group, and this will be the final answer. Again, we cannot add the alkyl group first because it's going to turn out to become a different compound. It must follow the synthetic sequences. Okay, let's go back to the first question just now. Alright, just now we already answered question B. Now let's take a look at question A. Now let's do this. Ortho-nitrobenzoic acid. First, draw the overall reaction. We have benzene. And then the end product will be benzoic acid is COOH, while the nitro is positioned at ortho configuration, which means it's 1, 2. Right? 1, 2. Okay. For this question, actually requires 3 steps of reaction. It's a little bit tricky because, again, you know how to insert the NO2. Okay, for the COH, we'll have a different approach. However, if you look at the list, NO2 is a meta-director. The COH also a meta-director. However, the structure is in ortho configuration. It might sound a little bit tricky. Okay, macam mana dua-dua adalah meta-director, tapi structure in the end will be ortho. Right, it's quite confusing. Okay, this requires us to look a step back to see the COH. Before it becoming a COH, it was originated from the alkyl group. Right, after we oxidize it by using potassium permanganate, then it turn into COH. So how to answer this question? We're going to start off with benzene, and then we're going to perform the Friedrich-Kraft alkylation to add the carbon into the ring. So we just use a simple structure of CH3Cl catalyzed by AlCl3, then we're going to get CH3. Since CH3 is from group R and R is the ortho-para, from this step, we're going to add the nitro first by adding nitric acid together with sulfuric acid. So we're going to come up with 2 structures. The first structure is CH3 with the NO2 on the ortho position. The other one will be CH3 on the NO2 at the para position. So between these two, we're going to take the ortho structure, since the question ask for an ortho configuration structure. So we can ignore the para structure. The next step is we're going to convert the CH3 into COH by using oxidation reaction. So oxidation reaction is quite familiar for you guys. So we're going to use potassium permanganate in acidified medium as the strong oxidizing agent. So what's going to happen is any carbon which is directly attached to this benzene ring will be converted into COH, while the nitro will remain the same. Then we're going to get our desired structure. Alright, mungkin akan ada yang tertanya, what happen if instead of adding the nitrogen first, we perform the oxidation? So basically, it will be looking like this. Okay, let's say, starting from here, we start it correctly by performing the alkylation. Let's say from here, okay, what happen if we perform the oxidation first? If we perform the oxidation first, what's going to happen is the CH3 will be converted into carboxylic acid first. So we are going to have benzoic acid. At this point of the reaction, the ortho-para director properties has changed into meta-director because COH is a meta-director. So after we add the nitro afterwards, by adding nitric acid together with the sulfuric acid, instead of going to the ortho position, it will go into the meta position, which is not the desired structure that we are looking for. So that's why the NO2 must be inserted before the oxidation being executed. Okay, that's all for this video. Please do the practice in your tutorial, and then we discuss it in the Telegram group. Okay, goodbye.